video, we are going to be discussing how to multiply radicals using monomials. So there's one thing you need to understand first before you are capable of multiplying radicals, is that the index of the two radicals that you were trying to multiply together must be the exact same. So if you have a square root and a cubed root and you're trying to multiply those together, you can't. You just leave them alone. It's kind of like one is x and one is y. X times y is still xy. You just leave them alone. But if they are the exact same index, you can multiply together. Just like x times x is x squared, we can actually multiply the square root times the square root of something. So when you are multiplying two radicals together that do have the same index, you multiply the coefficients together and you multiply the radical or radicands together. So for this first example that we can look at, we have the square root of 3 times the square root of 6. So if you notice, both of these radicals have a coefficient of 1. So when I multiply these two coefficients, 1 times 1 is still 1. And then I can go and I can multiply the insides, the radicands. So I can multiply 3 times 6. So that gives me the square root, since we're still talking about the square root times the square root, of 18. So here we can simplify. So the largest square root inside of 18 would be 9, so this is a perfect square. So this is the square root of 9 times the square root of 2. And that 1 is still outside, but you don't need it. So the square root of 9 is 3. So this is the 3 times the square root of 2. So that is multiplying radicals together. So again, they have to have the same index. You then multiply the coefficients, then the radicands, and simplify when you can. So let's look at another example. So we have 2 times the square root of 12 times 3 times the square root of 15. Now, a lot of times, what you should do before you even start working on a multiplication problem is see if you can simplify the radicals first, because it is so much easier to work with after you've simplified the radical. Because beforehand, we're going to need to multiply 12 and 15 together, and that's going to produce a large number. Then me trying to simplify it is going to be a pain. So let's simplify first. So the square root of 15 is as simplified as it can possibly be, but the square root of 12 is not. So the square root of 12, we have a perfect square of 4. So this is going to be 2 times the square root of 4 times the square root of 3, and that makes up that square root of 12. So we're still multiplying. So the square root of 4 is just 2. So this is 2 times the square root of 3 times the square root of 15. So we can simplify it further. So 2 times 2 gives us 4. And now we're at a place where we can do this math a lot easier than having to multiply 12 times 15 together. 3 times 15 is a lot easier of a number to simplify. So let's start by multiplying our coefficients. So I'm going to multiply this 4 and this 3 to give me 12. So we need to multiply the 3 and the 15 now, because those are our radicands, and that gives me 45. So I can simplify the square root of 45. That is going to give me the perfect square of 9 times the square root of 5. So this is just 3, so we get 12 times 3 times the square root of 5. So this is 36 times the square root of 5 as our final answer. And that is multiplying radicals. So again, simplify first, because otherwise you would have needed to multiply that 12 and that 15 together, giving you 180, and then you try to simplify 180 by trying to find the largest square root that is in there, and the largest square root in 180 would have been 36, so 6 squared. But again, simplifying first, you're working with smaller numbers, and smaller numbers are always easier to work with in the long run. So always, always, always simplify. You will hear me say simplify before almost any problem we ever work with. So I have some u tries for you to try. So we have the cubed root of 6 times the cubed root of 9. We have 4 times the square root of 27 times 2 times the square root of 3. So go ahead and work through, or pause this video, work them out, and when you're done, you can check. All right, so on the first one, you should have gotten 3 times the cubed root of 2. And on the second one, you would have gotten 72. So again, if you did not get these right away, that's fine. Go back, look over your work, see where your mistake may have been, especially with that cubed root. Remember, you are looking for perfect cubes this time for that first problem. And on the second problem, it is okay to come out with a integer. You don't need to have square roots when you simplify things.